Hey kiddos, today we're going to do Unit 8, Lesson 2. It should go a lot quicker than Lesson 1 did yesterday, okay? We are going to discuss square root and cube root functions, and they look different. So this is a square root function, and this is a cube root function. Now, the square root function, you can kind of think of it as 1/2 of a parabola. So if I turn it this way, you can see that it just goes up and to the left in one direction. A parabola would go in both directions. Okay, so remember that square root functions have that plus or minus, which allows them to still be a function while only showing 1/2 at a time. Okay, and then our cube root function is like a silly little squiggle, which is kind of like the opposite of a cubic function. Okay, a cubic function would look like this if I turned this on its side. So there is a strong relationship here between cubic and cube root functions, quadratic and square root functions, okay, because they're inverses of one another. So for both of them, I have the n here for the nth root, and that's the only thing about them that's really different, that and what their graphs look like. They both have these same 3 key features that operate the same way. So H is our horizontal shift. It shifts things left and right. K is the vertical shift, and it shifts our function up and down. And the end point or turning point. So in a square root function, it's the end point. In a cubic root function, it's this little squiggle in the middle where it changes directions. Okay? And so that would be similar to us thinking about our vertex in a quadratic. And then everything that has to do with the a value. If the a value is negative, just like before, it reflects our function over the x-axis. If a is greater than 1, or the absolute value of a is greater than 1, then I have this stretch where it kind of makes it taller, okay? And if I have a compression where a is between 0 and 1, so an example would be 3 quarters, okay? Then I would have this compression where it kind of squishes it down and ultimately makes it look a little fatter sometimes. So let's just get a little bit of practice in with identifying the key features of these functions from the parent functions. Okay, so these are the parent functions over here. So inside the square or cubed root, okay, is the horizontal shift. And remember that we always need to do the opposite for that, okay? So this is going to be a shift to the right, 7. And then the K value is on the outside, and that is going to go up 2. Okay? Very, very similar to our vertex form of a quadratic function. In example 2, so I have this -1 for my K value out here. That tells me that I'm going to shift down 1. And my A value is a 4. So it will be a vertical stretch, okay? Vertical stretch by 4. Okay? All right, example 3. I see a negative outside in front of the root, and so that's like a -1. So that tells me that this function will reflect over the x-axis. And Then inside my root, I have this plus 3. So this is going to shift my function to the left 3. Okay. And finally, example number 4 here. So I have a vertical compression by 1/2. Okay. I will have a shift to the right 2 and a shift that goes down 6. Okay. So that is how I identify transformations of the functions when they're being compared to their parent function. Okay. All right. Let's look at 2 examples of how we identify the key features and graph it. And just to get an idea of what it looks like, you will ultimately always have a calculator for the most part. So we're just going to do one example of a cubic and one of a square root function, okay? So, or cube root rather. So again, I need to identify my features, okay? This -1 tells me that it will reflect over the x-axis. So reflect over the x-axis. This 2 tells me that it will move to the right 2 spaces. And this +3 tells me that it will go up 3. And so here's how I take that information and put together my turning point. So the x value is going to be 2. The y value will be 3. And then let me find my black pen. And then I just wrap those up as an ordered pair. Okay, so my turning point is at 2, 3. So I'm going to go over 2, up 1, 2, 3. Okay. Now, because I am doing a square root function, this is going to be the end point. The end point. Okay. Now, I use that end point to help me determine the domain and the range. So, because this is a reflection over the x-axis, instead of going up and to the right, this is going to go down and to the right. Okay. And so my domain, my x values are going to be greater than or equal to 2 because the x values are going in the positive direction starting at 2. What about the y values? What about the y values? Well, the y values going up and down, they start at this 3, the end point 3, and the y values are going to be decreasing, going down. So this is going to be less than or equal to 3. Okay? And so because it was a reflection over the x-axis, it made my range be less than or equal to. Okay, so when you have this, the range becomes less than or equal to. If this was a positive, the range would be greater than or equal to. Okay, so -1 equals that for the range. All right. What about our end behavior? So on the x side, let me go back to using my blue, okay? As x is going to infinity, right? It's going to the right forever. What is the y value doing? The y value is going in a downward direction to infinity. Okay. All right. What about as x x is at 2, and so the y, f of x, is at 3, okay? All right, and so increasing intervals. We've never really talked about interval notation before, so I'm just going to introduce it. This one is actually going down, so there is no increasing interval, but there is a decreasing interval. So here's what's happening. It is starting at 2. It is starting at 2, and I'm going to use a nice rigid bracket here because it is a definite stopping point. And then I'm going to do a comma, and it is going to move on to infinity. And on this side, I'm going to use a soft parenthesis because there is no definitive stopping point. Okay. And so this is really how we do interval notation. Okay. All right. So that is a square root function. Let's look at a cube root function. So again, I'm going to identify the same features. So this is a positive value. This is a positive value, but it is a compression of 1/2 or by 1/2, okay? So it's going to take the function and kind of squish it down. That's all that means. Okay, my turning point in this situation will be -1, comma, -5. That's going to be the turning point, and I get those values from here. Okay, so let me go ahead and write those. -1, comma, -5. And then I just need to be sure that I wrap this up as an ordered pair. And I'm going to go ahead and just say that this is a turning point now because it's a cube root function. Okay, so here's what this kind of looks like. So I'm going to go plot this point, -1, -5, 1, 2, 3, 4, 5. Okay, and so this is the turning point. And if you wanted to get some more exact points for this, you could always type it into your TI-84 calculator and go look at the table. Or you could even type it into Desmos and just try to identify some points on your own. Okay. But I know that it is going to be over, let's see, 1, 2, 3, 1, 2. It's going to be really close to there. Okay. And then it kind of is going to look like this, guys. Okay. I did a poor job of drawing that real great, but that is where that little turn point happens. Okay, so now what is happening with my domain and range? Well, my x values are going positive forever and negative forever. Okay. And so are my y values. It's going to go up forever. I mean, it's very slightly up, but it's going up forever and down forever. So both my domain and my range are all real numbers in this case. Okay. So as the x values are going to positive infinity, the y values are also constantly going to positive infinity. And as the next values are going to negative infinity, it's also going down in that direction as well to negative infinity. Okay, so that's my end behavior. And then in this situation, I do have an increasing interval. Okay, So that is going to be from negative infinity to positive infinity. And keep these curves, okay, on the side there. All right, and then no decreasing. Okay, so if the A value is a negative, that's when we have a decreasing interval. If it's positive, we use the increasing. Okay, so we're pretty much done for today. I just want to introduce you to a lot of the other parent functions as well and give them all to you, all of these functions in their vertex form, okay, just so that we can kind of compare them. And I also drew them for you. So linear, exponential, quadratic, you learned about all three of those in Math 1. We haven't done a lot with cubic or absolute value, but those also exist. And then today we discussed square root and cube root functions, okay? And so this is what their forms look like. This is the horizontal and vertical shifts. So here's what we're going to do with these last 4 examples down here. I'm going to give you f of x in a graph, and then we're going to translate f of x, and that translation, we will call it g of x, okay? So we're going to identify what parent function am I looking at, or what family does this belong to, family of functions, and then I'm going to sketch the change. So let's do that. So that's also why I kind of drew all these out here for you, just so that you'd have a reference. So this very first one, that belongs to the cubic function family. Okay, it is a cubic function. And so this is going to be translated, this is inside parentheses, so it's going to go to the right 5. It's going to go to the right 5. All right, and so here's what that would look like if I put it into the cubic function. It'll be y equals parentheses x minus 5 cubed. Okay, minus 5 cubed. And so we're going to move that to the right 5 spaces. So let's 1, 2, 3, 4. Here's the 5. And I guess it doesn't have to be perfect as long as you get the basic idea of what it should look like. Okay. All right. What family of functions does this belong to? This is certainly a quadratic function. Okay. And so this quadratic function is going to be y equals x. Okay, this 3 is on the outside of the parentheses, so nothing is going to change inside there, but it will move down 3, down 3. And so there is no shift left or right, just down 3. So go down 1, 2, 3. There it is. And so it'll look just like the original, but down some. Okay. All right, 2 more, and then we're done looking at our different families of functions. So this is a square root function. Square root function. Okay, the square root function, let me go ahead and write what that is. Y equals the square root of x minus 1, and then the plus 3 is outside. So this is going to go to the right 1 and up 3. to the right 1 and up 3. And then just kind of notice how it goes up by what looks like a slope of 1 at first, and then it starts to level out. Okay. All right. And then finally, this is an absolute value function. And we haven't really looked at absolute value functions, but if you think about the absolute value of 2 and -2 always comes out to the same final answer of just +2. So if I have a +2, I get out a 2. And if I have a -2 absolute value, I also get out a +2. So it kind of creates this V shape. All right. So y equals the absolute value of x plus 2 minus 1. So what that means is that the vertex of this function is going to go left 2, and down 1. Left 2 and down 1. And then I would just do my v. Try anyway, right? I'm no good at these straight lines. Okay, and so that is what we end up with. Okay, guys, so today we really just got introduced to new function families, but our primary focus was on square root and cube root functions, just because that's the unit that we're in is dealing with square and cube roots, right? Radicals. All right, so that's it for today. Until next time.